Today we are going to be talking about a design life cycle of a building. We'll be focusing more of on a difference between how things are different when you get out from college and when you pass out your graduation or your postgraduates and when you get into the industry. So me and I've seen a lot of people after me coming in. I've myself experienced it. I have seen them experience the transition phase, and it's there are a lot of differences that we'll be kind of going through from slide by slide. But before beginning this one, I would just like to put a question in here, which I also had to answer right in the beginning of my career. And that question was like, what exactly is the difference when you get into the actual industry, when you have to actually design the building? Like you're doing the same thing. You're going to design the columns, beams, foundations, slabs in the college, as well as when you get into the industry, you're going to do the same thing. But still, there are some differences. So, can I hope what is the difference when you come out of college and when you go into the industry, you'll be doing the same design stuff, designing beams, columns, foundations, and other structural elements. But still, there is some difference. Can some of you try and answer? Okay, so the answer is like when you are in the college, you get all your data. You know what's going to be your loads that are acting on a beam. If we take example of a beam design, you know what loads going to act on a slab, what kind of conditions are there, whether that's a fixed beam, whether that's a pin, whether that's a prop cantilever, whether that's a cantilever. But when you get into your industry, into the actual life scenario, you don't know what kind of condition is there. There is no one going to come in and state that, okay, this is the load that's acting on the beam. This would be the condition, support conditions. This would be the span of the beam. This would be the location of column. It's all you who have to decide it. It's all you have to work it out. So just to sum it all up, in your college life, in your curriculums, you know what's the problem. But when you get into the industry, you yourself have to find out the problem and you yourself have to come up with the solution. So that's where I have seen, as I stated again in the beginning, that's where I have seen it's a major difference between major gap between the curriculums and when you get into the actual industry, into the actual life. So that's where I have seen people struggling a little bit. So we'll go through this presentation and we'll talk about these kind of things where you have to find out the problem and you have to come up with an efficient and effective solution. Talking about contents of the presentation, these are few bullet points that I want to highlight. And now again, before going into these points, I'd like to mention this is not all. These are just some of the major points that are there. There is a lot more before this, before receiving information from client and architect. There is a lot more into the project that goes in. And after coordination with other disciplines like AMEPC, there is still a lot more that is going to happen in a project life cycle after this point. But I'm just going to cover the major points that you guys, as a fresher, when you'll be going into the industry, you'll be doing. Majority of you guys would be in your beginning, in your first 1 to 3 years of your career cycle. You'll be doing these kind of tasks depending on the type of project that you're doing. So we'll be talking about these points. Like first thing would be when you receive your information from clients and architects, then you go in and you start laying out your framing, gravity and lateral. You go through again the information that comes in is Geotech report as well. So you go through that once you had your framing laid out and stuff, and you decide what kind of foundations you'll be doing, and then you work out your loads. Then you go into your design, gravity and lateral, and at the last I'm putting up coordination with other disciplines like AMEPC. So these are the bullet points. We'll be going point by point and talking about the first point. When you receive the information from your clients or like architects, so clients can be your contractors, clients can be a direct client, a direct industry that wants to get in touch with you and get the structure design, or in majority of the cases our client is architects. So they come in and they give you the information what kind of building they want. So what kind of information you're looking for before starting the project, that would be your architectural drawings. We want the site plans, we want the grading plans, we want the geotech report, and if there is any other special requirement that needs to be fulfilled in a particular project. What would a architectural drawing look like? So I've just put a snapshot in here to show what kind of information architects generally go in and show. So I hope you guys can see it, and I hope you guys can see my cursor moving around. So this is a plan of a building, a very small building, not a big one. But this is what an architect shows, or whether it's a big building, even though, but the plan would look something like this. So they'll show that where they want the walls to be, how they want the building to be laid out. They'll be showing the doors, windows, and panels, and they'll be showing all the internal elements. In some of the plans, I've just put one plan in here. In some of the plans, they'll be showing their ceiling layout, they'll be showing their furniture layout, they'll be showing the room layout. There'll be a lot of architectural plans, but for a structural engineer, what we would be looking at that where they want the walls to be laid out and what kind of material that is going into the wall. So basically, this is what an architectural drawing would look like. An architectural drawing, and particularly the layout of an architectural drawing or architectural plan would look like. And this layout is very important to us. Without this layout, you cannot proceed further. Now, again stating there is difference when you go into the actual industry. There are not always ideal case scenarios. In some of the projects, it might happen that architects, they don't have the layout ready, or they don't have the complete layout ready, so they might give you certain ideas in different formats. Like they might give you a simple PDF where they have done some very initial level or very schematic planning, schematic in the sense just a very rough layout. So you, depending on whatever the situation is, you have to go in and look at this, and then there'll be next steps coming further. So next thing would be, we would be trying to have a look at is talking about elevations. Why would a structural engineer bother about elevations? I mean, it's always an architectural element. They want to go in, and it's architects kind of forte, where they want to show how they want to have their building look like, what kind of exterior elements they want to have, what kind of roof they want to have, what is the height of the building. So elevations we want to look at, because we'll be laying out our framing, our structural elements, your columns, your beams, your lateral elements. So without looking at the elevations, if you lay out your framing, there are chances that you might end up having a column somewhere in between of a window. Like if you guys could see my cursor moving around, this is a window here. If you put a column somewhere in between the window, and you send that layout to your client saying that, okay, this is the kind of framing we are kind of planning to come up with, and this is a column sitting right in the middle of the window, you'll be creating not so good impression for not so good first impression. So again, elevations are very important. You don't want to put a column somewhere in between the door. So looking at the elevations, important kind of aspect for a structural engineer to begin with. Now, again, as I mentioned previously, that once you have your layout, you also want to have a look at the site plan, how your site would be looking at. And when we talk about site, there are a lot of things that go into a site plan. There is going to be what all buildings are going to come in, what all kind of structures are going to come in. There are a lot other elements on the site, like this one is a fueling station, so there can be parking in there. There is going to be a fuel tank, underground fuel tank, and there are going to be some passages. There are going to be some signages. There are going to be some, as I said, parking, some charging points and kind of stuff. So you all want to look at the site plan just to know what all structural elements that are on a site that you would have to design upon. Now, again, coming on to the first point that I mentioned, in the college, in your curriculums, you guys are told that you need to design this beam, you need to design this column, or this is the building information and you need to design this building. Now, this is an actual case scenario. I'm giving you the site plan. There is no one to tell you what all structural elements are in there, at what all locations input from a structural engineer would be required, what all things would be required to be shown in structural drawings. There is no one to tell you that. It's all you on your own, on yourself, who have to decide what's the forte of a structure engineer, and what all information would be going into the drawings, what all information would be going into my general notes, what all information would be going into my specifications, and what all information would be going into other kind of documents at what stages. So that's where the challenge comes into the picture. And please don't worry, you guys, when you go into the industry, there is nothing like that you would be just given the drawings and you'd be asked to do the whole project on your own. I'm pretty much sure in most of the industries, in most of the companies, there are seniors sitting up there to guide you, to help you, to look after you. So you'll be getting regular guidance as I gotten. But then moving further ahead, slowly and gradually, you guys have to come up with, you guys have to develop that skill set altogether. You guys have to learn it. That what's the responsibility of a structural engineer in terms of drawings, in terms of designing, in terms of laying out in the drawings, marking up in the drawings, marking up in the specs, and a lot more. Just to quote some of the examples. Okay, so site plan, these are the reasons we need, there are a few reasons that we need the site plan for. So we covered up the site plan stuff. Now talking about grading plan. Again, when I get the information from my client, in some of the cases, client would be smart enough, experienced enough to give you all the information all straight up ahead on the first day, or in the subsequent days when the project progresses during the design life cycle. But what if a client is also very new and you are also very new, and there are certain information, just to quote an example, a grading plan is required, it's must when you're designing a building. And what if client is new, and what if you are new and you miss this information putting up into the structural drawings, you miss this information into inputs? It's going to be a huge blunder when you go on site. Let us say, just to quote an example, why do you need grading plan? One site is going to be all flat. You'll assume that, okay, my whole site is pretty much flat, there is not much slope actually coming into picture. But if you are putting up your site on plot or on a piece of land which is sloping a lot, and just to quote an example, let us say this is one of the building, and this is a grading plan wherein we are showing that, okay, this is what my grades levels look like. And in this one, you might not see much of the elevation change. But just to give you an explanation, if this is the building and this grade here is sloping, and one of my elevation on the grade is, let's say, somewhat 300 meters from 300 meters at this point, and when I come somewhere in middle of the building, my grade elevation changes to 80 meters. So it's a slope from this point to this point of 20 meters. The grade is very steep slope here from this point to this point. Now, being a structure engineer, what would impact here? That you're designing your foundations, your foundation bearing elevation at the level of 300 would be, let's say, 2 meters down. So 298. But when you come at this point, your grade is already at 280 meters. So how you're going to put your foundation at 298 meters? It's a difference of 18 meters. So you guys have to look at the grading plan. And when you look at the grading plan, you get to know that there is grade difference, a huge grade difference. So you would come to know that I have to cater this into my drawings. I have to put some foundations which are deep enough to rest on some solid bearing strata. So that's where your grading plan also comes into picture. And again, just to remind, this is not all. I'm just quoting some bullet points, some big examples, which are very kind of most likely happening on almost each and every site where you have to do almost on each and every building. These things have to be done depending on the building to building, on the project requirement, on the site requirement, on the client requirement. There are going to be lot many other things that are going to come into picture, and that you being a structure engineer would have to take care of. So this is what a grading plan would matter of. Now coming on to Geotech report. Now this is, I myself feel a lot. I don't know whether it has been quite a few years, 8, 9, 10 years since I have looked at any curriculum. I don't know whether this has been put into the curriculums or not, but I'm pretty much sure it is not. No, whether you're doing your graduations, whether you're doing your post graduations, no one talks about Geotech report. All you're given an example wherein you're asked to design a foundation, any X type of foundation, shallow foundation, deep foundation, any type of foundation in shallow type, or any type of foundation in deep foundation type, and you're given some geotech data that okay, if it's a pile, this it's going to be an end bearing pile, or it's going to be a friction pile, or it's going to be a pile with a bulb down there. So you're given all the input, all the cooked stuff to just go in and eat and do the design, and that's it. There's no one going to be ready to give you that information in actual condition in an actual project that you're working on. So all that you'd be getting is geotech report, and this very small geotech report. It has just 23 pages, as you can see, as you guys can see in here. Just to quote an example, but in some of the cases, you might get a geotech report that is 150 pages, and you have to read through all of it. There is a lot of data which is not relevant to us, which we are not bothered about, which we don't use. It's for the geotech, it's for the geotech contractor that is going to be, it's for the geotech report guys that is stated there. But still, it's in responsibility of a structure engineer to go through each and every page, each and every word that's written in the geotech report, and try to find out what's happening. Try to find out what kind of foundation is efficient there, what kind of foundation the geotech is recommending. Many a times it happens in a geotech report, they will recommend you three types of foundation. They'll say that okay, you go with shallow foundations wherein you have isolated footings, or they suggest that okay, you go with a raft footing or a mat footing which is shallow enough, and that would do the purpose, that would solve the purpose. And along with that, they'll also come up with okay, you can also have end bearing piles which you'll have to bear at a depth of 20 meters, at a depth of 30 meters. Now it's all upon you. What do you want to do? You want to go with a mat foundation, you want to go with an isolated footing, or you want to go with a pile foundation? How would you decide? And any of three is going to solve the purpose. Any of three is good enough. There's no foundation which is less than the other. But it will all come upon you. You'll have to decide which is going to be cheap enough, which is going to be easy enough to construct, which type of foundation has ready materials available in the nearby vicinity, so that again it's not a pain for the client, it's not extra money that I'm putting in, it all ends up upon you. If you on a foundation on a site, if you suggest that I want to do pile foundation, and if it is not required to do a pile foundation, you might end up with that project doing pile foundation, but you'll end up with a bad impression on client that this engineer, they suggest me costlier options. I mean, the nearby vicinity or the other engineer, he was suggesting me that shallow foundation is going to be good enough. So that client might not come back to you. They might not want to work with you in future. So it's all again a real life thing that you all have to face, and that I have been facing. I was struggling a lot when I was into the starting of my career. Not struggling in the sense, but I had a lot to learn. So again, quoting a very, I would say, cookbook example wherein you would see the difference, wherein you would see the requirement of a bridge between curriculum and your actual life cycle. Okay, so now coming on to the next point, laying out of framing, that is gravity and lateral. Now we're talking about kind of the same plan that I'm showing here. Previously, I was showing the architectural plan here. I would again go back onto the slide just to let you guys see it, have a look at it once again. So an architectural layout. Now the next thing that we're looking at is structural layout, wherein we have laid out framing. Now, when I say laid out the framing, it is again something upon a structural engineer. It comes upon a structural engineer to decide what kind of material, what kind of framing they want to have, whether they want to have a steel building, whether they want to have it built with concrete, whether they want to have built with precast, whether they want to do it with masonry. In some of the cases, you might get some examples, you might get some things that are laid out by architecture. Like, let's again, if we go back into plan, let's say, just to quote an example, if this wall architect is showing that it's a masonry wall, so why would I, if architects wants it to be masonry wall, if I want to have this wall as a structural wall, I would have to make it masonry structural wall. It can be reinforced, it can be not reinforced, but it's an architectural suggestion, so I have to go with it. But when we talk about framing here in this example, what we did is we had steel columns go in there. Why with the steel columns? There are a lot of things that to be thought about. Just to quote some of the examples, it's either the easily available material on site, or it's the ease of constructability, or it's some of the special requirements. So in this case, this is one of the special requirements. I won't quote which one it is, but there's one of the special requirements because of which we are going with a steel frame. So coming on to the main point, laying out the framing, and I specifically want to differentiate between gravity and lateral. Reason being, because when we talk about the Indian scenario, it's all about concrete. So when you talk about concrete, what we usually guys do is we just have columns up there, walls up there, and everything is taking lateral loads. But that's not the case with steel buildings. You cannot have each and every element take up lateral load. It's going to be very, very costly, and it's not required. And when I say cost, that's the first and foremost thing that comes into picture when you're working on an actual project for one of the clients, for one of, and whether it's a new one, whether it's your previous client or whatever it is, it's cost that always matters. So we go with steel framing laying out. Now, as you guys could see here, when I'm moving my cursor around, there are some column markings in there where we are seeing SC5, SC1. So these are steel columns that we laid out here. And as I quoted before, we look at the architectural plan, we look at the location of doors and windows, and I hope you guys can see it. I'm laying it out somewhere wherein I don't have doors or windows coming in between. I'm trying to hide it inside the architectural, somewhere inside the architectural element, so that it's not visible in the elevations and my building looks neat and clean. It's just those exterior elements that architects want to show. So basically I go in, I lay out my columns. Then once I have my columns laid out, next thing that I want to do is I want to move up on the roof level. Now again, on the roof level, if you're putting up steel columns up there, so my roof has to be on the roof, it has to be steel elements. So I'll again go in and put up steel elements spanning between the columns, and I want to have my main girders and I want to have my secondary girders all going in there. So this is what kind of laying out of framing would be. Now in this case, I'm putting up steel beams, some steel joist. I won't go into the detail what a steel joist would mean, because that would again be a separate whole chapter, a separate whole presentation, which would take a lot of time. So we'll focus on just kind of a steel joist is just to make you guys understand. It's kind of a prefabricated truss that comes in from factory, and it's actually lifted from with the help of a crane, and you put it up there wherever required as per the structural drawings, as per your construction drawings. So your steel beams, your steel joist, and then you lay out your secondary framing wherein you want to have your the other elements that are sitting on the roof supported on there, and then you put up a metal deck on top of it. Again, a metal deck, when we talk about Indian case scenario, I suppose most of you guys might not be aware of what a metal deck is. So it's just a corrugated roof deck which is made up of steel, pretty light gauge, pretty lightweight. But when you put it effectively, it's good enough to take up some load there. So this is again wherein you are using your material efficiently to reduce the cost, to come up with a efficient option or efficient framing thing laid out there. Now continuing again on the layout of framing, but the next point is lateral part of it, lateral framing. So what's when I said differentiate between gravity and lateral, I'm trying to show here some of the elevations again, wherein I hope you guys could see these bracings, these inverted K bracings, or whatever you or V bracing, whatever name you want, whatever thing you want to name it. So in this elevation on this front of the building, which is front portion, if I'm not wrong, yeah, front. So you want to have your front elevation wherein you want to have this K brace take up all the lateral load that is going to act on the building in this direction, maybe because of wind load, maybe because of seismic load, or maybe because of certain other lateral loads that can come in depending on the site or depending on the conditions there, the local conditions there. And similarly, on the other elevations, on the back elevation, on the side elevation, I'm trying to differentiate my lateral frames and my gravity frames. So gravity frames, I won't be going in and showing up that these are my gravity frames or this is what my gravity frame would look like. But all I want to highlight is that these are my lateral frames. Apart from that, it's all gravity. Now, again, giving you a highlight on when I said you guys have to decide what my problem is and you guys have to decide what kind of solution I'm going to come up with. So you have to go in, look at the architectural plan, look at the architectural elevations, look at the other conditions that you have, look at the other specific requirements that you have from the client, from the building, from the site, from the locally available material, any special requirements that you have, and there are a lot more examples to quote in. And based on that, you have to work out your gravity framing, you have to work out your lateral framing, how it is going to be, how it is going to look, which one would be cheaper, what option would solve my purpose, and what would be labor intensive, what would be not labor intensive, what would be material intensive, what would be not material intensive, and there are a lot of other things to juggle with. And believe me, in college, in curriculums, we guys are taught that okay, this is how a concrete frame would look like, this is how a steel frame would look like, and these are the specifics that you have to go in and design into a concrete frame and into a steel frame. But no one in your curriculums ever talks about what are other factors that impact your design. And believe me, your design is all impacted, 99% of your design is impacted by non-technical items. It's not dependent on what would solve your strength requirements. It's not based upon what would solve your deflection requirements. It's not based upon what would solve your detailing requirement. It's all based upon the other factors, like what client what wants his building to look like, what kind of material is locally available, what kind of stuff is cheaper, what kind of stuff is less labor intensive. All these factors do jump in, and based on those factors, you have to come up with a type of frame, whether you want to go with precast, whether you want to go with steel, whether you want to go with masonry, whether you want to go with prefabricated elements. Prefabricated elements can be light gauge, can be steel, can be masonry, can be concrete, can be precast, can be tilt-up panels. There's huge list down there, which you guys would. I'm not saying that you have to kind of go into the industry and learn all these things. This takes time. It takes maybe 2, 3, 4 years down the line. You guys would get used to these things, and these would be your kind of daily activities that you would be doing into all the projects you work upon. Okay, so once you have your framing laid out, your columns, your lateral frames, your roof elements, this is what your building would look like. It's a snapshot from one of the softwares that we use to do 3D modeling, as well as to produce the drawings, as well as to produce the 3D kind of views. But and there are a lot of softwares available in the industry that you could use depending on what your company wants and what they are comfortable with, or what in some of the cases wherein you have to use what your client wants. Again, depending on the project requirement, on the client's requirement, you have to juggle between some of the softwares in and out. So again, to quote an example, I hope you guys could see these the pink elements up there. These are all for the built-up roof that we were seeing in elevation here. My structural roof is sitting somewhere here, and this is built-up roof on top of it. To quote an example, this built-up roof, for this case, we went with steel, which is a very costlier option, I would say. This can be done with light gauge. This can be done with wood. This can be done with few other materials, few other stuff, few other construction techniques available in the industry. There are special contractors who come in and do these things for us. We as a structural engineer don't need to go in and do the all the detailed design up there. But again, based on the client's requirement, based on the project's requirement, we go in and we decide what needs to be done. But it's not as simple as that you just felt that okay, I want to do it for my client, I want to look at all with all the strength, with all the stability up there. I mean, there's no way this building is going to fall down, so I'll put up all my might in there, even though if it's costlier. If you're going with that option, you have to be confident enough. You have to take your client into confidence, and then you have to recommend anything. If not, then as I mentioned before, you might end up with an impression which you don't want to be there in your client's mind. So just be careful with these kind of things coming in picture, which I will again say, no need to worry about, no need to bother about. This is not what you'll be required to do right on the day when you go into the industry, but something you need to learn down your career cycle.